So today we have a cool geometrical problem. The given diagram is on the screen. These two sectors are quarter circles. This quadrilateral is a square. All you have to find is the combined area of these two triangles, that is equals to the right area. So let us see the solution. How can we solve for this? So first of all, we can see that the only numerical value given in this question is the radius of this quarter circles, that is equals to 4. This means that the right area depends upon it. So why not take it as a variable, let it be equals to a. The radius of the quarter circle has been taken as a. And now let us find the right area, that is the combined area of these two triangles in terms of a. And when we will get the right area in terms of a, we will replace a with 4 so as to get the answer of this particular question. So here we have taken the radius of this quarter circle as equals to a. Now let us move on to the solution. So we will start the solution by finding the area of this bottom triangle. So as it has been given that these two sectors are quadrant circles, so here this angle becomes 90 degree and on the top that angle becomes 90 degree. And now what I will do is consider this particular angle over here as some variable, let it be equals to theta. So this angle as equals to theta, and again we will take this particular angle as equals to alpha. Now what we can observe is that theta and alpha are inscribed as a corner of this particular square. So we have that theta plus alpha as equals to 90 degree because it is at the corner of the square. Now let us take this particular angle as equals to beta. Now again we can see that alpha plus beta is the corner of this quadrant circles. So alpha plus beta will also give me 90 degree because it is the corner of this quadrant circles. Now by simplifying this equation, we will get that beta is equals to theta. So in this diagram, the angle beta is equals to theta. So let us replace beta from here with theta. So this beta is equals to theta. Now this will be utilized to find the area of this top triangle. We will see that in a moment. Now let us find the area of this bottom one. Now let us take the side length of this square as a variable. So let it be equals to y. So here that is equals to y. This length is equals to y. All these four lengths is also equals to y because it is a square. So all four sides are equal. Okay. Now we can again observe that this length is the radius. Also this is the radius of this quadrant circle. So radius is equals to a. So this length is also going to be equals to a. Now using this data, let us find the area of this bottom triangle. So we all are familiar with this particular formula for the area of the triangle, that if we have a triangle, there is an angle theta and adjacent sides are a and b. Therefore the area of the triangle is half of sine of theta into a into b. So over here we will take this particular angle for this bottom triangle. So half the angle present over here is 90 plus theta. The triangle is like this way. Here's the 90 degree and here's the angle theta. So the complete angle forms over there is 90 plus theta. So sine of 90 plus theta is going to be equals to cos theta. So we'll directly write cos theta multiplied with adjacent side. Now adjacent side is a and that adjacent side is y. So a into y. Now look carefully that the angle theta is inscribed in this particular right angle triangle, and it has been asked to find the value of cos of theta to put it in this bottom triangle's area. So let it be equals to area 1. Okay. So we need the value of cos of theta. So from this right angle triangle, we have the value of cos of theta as adjacent upon the hypotenuse. So from that right angle triangle, the value of cos of theta is going to be equals to a upon y. So let us replace cos theta for the area 1 as a upon y. So it will turn out to be half of a upon y multiplied with a into y. So y and y got cancelled out. We have area 1 in terms of a, that is equals to a square upon 2. There's another way to find the area of this bottom triangle. You can just extend the base, draw a perpendicular from that point over here as a 90 degree. So this particular quadrilateral three angles are 90 degrees, so both become 90 degrees, so it forms a rectangle. So this side is a, so that side becomes a. Now you can see that this triangle is an obtuse angle triangle because the angle is 90 plus theta. So the area of that becomes half of the base, that is equals to a because this is the base, and as this height is equals to a, so the area becomes a square upon 2. You can see that we got the same area. Can even use this particular method so as to get the area 1. Why I preferred this method? Because here we have marked some of the angles and some of the side lengths and found some of the values. So this all will be required to find the area 2, that is the area of this upper triangle. So let us see that in another diagram. So here we have another diagram same to same as the previous one. Now here we will try to solve for the area of this upper triangle. So to do so, we will draw a line segment from that particular point to this particular point. Now look carefully, the line segment that we just drew is the diagonal of the square. So if the side of the square is considered as y, so what can you say about the length of the diagonal? It's very simple, the diagonal is going to be equals to root 2 times y. So now let us label this diagram also. So let this particular point be a, this point as b, this point over here be equals to c, and that point at the top be equals to d. So db is the diagonal, so it is going to have a length that is root 2 times y. Okay. Now let us have the area of this triangle, that is the upper right triangle. But we cannot have the area of that particular triangle as a direct formula. We have to get its area as a subtractions of area. So let us derive it. So first of all, we'll take the area of this triangle, that is triangle ABD. You can look in this diagram where the triangle ABD is. We'll add this triangle with the area of this particular triangle, that is triangle DCB. So these two areas when added, that is triangle ABD plus area of the triangle DCB. Now we'll subtract the area of this particular triangle, that is triangle ACB. Now let's see in this diagram also. We took the area of this triangle ABD, added with the area of the triangle DBC, and what we subtracted is the area of this triangle, that is triangle ACB. So what area is remaining is only the right area. So this equation is absolutely correct. So now let us find the area of these three separately. So to do so, we'll just zoom at this particular point P. So as we have considered this particular angle as theta, and we have derived that this angle is also equals to theta. Okay. Now as dB is the diagonal of this square, so this angle over here becomes 45 degree, and this complete angle becomes 45 degree. And out of that 45, this particular angle is already equals to theta. So this remaining is going to be the larger minus the smaller. So this particular is going to be equals to 45 minus theta. This length is the diagonal, and it is going to have a length root 2 times y. Okay. Now let us find the area of this first triangle, that is the area of the triangle ABD. So as per this familiar rule that in a triangle, if that angle is theta, adjacent sides are A and B. Therefore the area is half sine theta A and B. Now applying that same thing in the triangle ABD. This middle angle is 45 plus theta. The adjacent side is root 2 times y. And AB is already the radius, and we have taken radius as equals to A. Therefore area of this triangle ABD is going to be equals to half sine of middle angle, that is sine of 45 plus theta. So sine of 45 plus theta into adjacent side, that is root 2 times y multiplied with A. Now we have to add this particular area with the area of the triangle DCB. Now look in this triangle DBC, the middle angle is 45 minus theta. One of the adjacent side is root 2 times y, and the other adjacent side, that is BC, is already the radius, and it is going to have a length equals to A. So now let us write down the area of the triangle DCB. So it is going to be equals to half the sine of middle angle, that is sine of 45 minus theta. So 45 minus theta into adjacent side. One of the adjacent side is root 2 times y, and other is equals to A. And now we have to subtract the area of the triangle ACB. So in this particular diagram, the triangle ACB is a right angle triangle like this way. This side is also equals to A, and that side is also equals to A, because AB and BC are the radius of these quadrant circles. So its area is going to be equals to half base into height. So it is going to be equals to A into A. So first of all, what we will do is open this up, that is sine of 45 plus theta and sine of 45 minus theta, using these two identities. That sine of A plus B is sine A cos B plus cos A sin B, and sine of 45 minus theta will open with this particular identity, that sine of A minus B is sine A cos B minus cos A sin B. And also we can see that if A is taken as 45 and B is taken theta in both the cases, so what we will have is like this way: sine of 45 into cos of theta plus cos of 45 into sine of theta. I am opening this particular thing over here. So cos of 45 into sine theta. Now sine 45 and cos 45 has the same value, that is 1 upon square root of 2. So we can easily take it out common. And here in this particular case, we will have the same thing, just instead of positive, we will have negative. So again, we can take sine of 45, that is 1 upon square root of 2 taken common. So let us write it down as a final thing over here. So what we are going to have is first of all half. Now sine of 45 plus theta has turned out to be 1 upon square root of 2 multiplied with sine theta plus cos theta multiplied with root 2 times y into A. So this is the first area. Now let us see the second area. Added with the second area, that is half of 1 upon square root of 2 taken common. Inside the bracket, cos of theta minus sine of theta multiplied with root 2 times y multiplied with A, and minus A square upon 2, that is the third area. Now let us solve it. So we can clearly see that square root of 2 got cancelled out. Over here also square root of 2 got cancelled out. Now let us open the brackets. So over here we will have ya upon multiplied with cos theta plus ya upon 2 multiplied with sin theta added with ya upon 2 into cos theta minus ya upon 2 into sin theta and minus a square upon 2. So here we can say that y into a into sin theta upon 2 is positive, and here we have y into a into sin theta upon 2 negative. So they both got cancelled out. So what is finally remaining is addition of this plus this and subtraction of this. So let us see that also. So addition of this and this will give me y into a into cos theta minus a square upon 2 as it is. Now remember that we have the value of cos of theta. Look over here, we have the value of cos of theta from this particular right angle triangle, that is equals to a upon y. So let us put that over there. So as we just saw that the value of cos of theta is going to be equals to a upon y, this is multiplied with a into y and minus a square upon 2. y and y got cancelled out. What is remaining is a square, and we have to subtract a square upon 2. So this thing will give me just a square upon 2. So this is the area 2. So here we got area 2 in the terms of a, and we already have the area 1 in terms of a that is present over here. That is also a square upon 2, and this is also a square upon 2. Wow, that's something awesome, that these two triangles have the same area, that is equals to a square upon 2. Now the total rad area, so total rad area is going to be equals to area 1 plus area 2. Now both of them is a square upon 2, a square upon 2. So a square upon 2 plus a square upon 2 will give me a square. So this is the final rad area. Now talking about this particular question, we have to replace a is equals to 4 so as to get the answer to this one. So if a is equals to 4, the rad area is going to be equals to 4 square, that is equals to 16. So rad area is equals to 16 unit square, and that's the answer. So here we finally have the answer to this particular question, that is 16 unit square. But the most important thing is that the rad area is equals to a square. That's more fascinating. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram or Discord. The links are in the description.